This is Anthony Priscilla, graphing tangent and cotangent curves with my trigonometry class today, as if I'd been graphing these in some other class. Of course, it's trigonometry. Graphing tangent and cotangent. And the basic shapes for, let's do y equals, I'm going to go ahead and write it as a times tangent x. And that a doesn't stand for amplitude. We've seen that the graphs of sine and cosine are the only ones that have amplitude defined. A is just going to be some positive number. When we graph these, the thing you're going to have to remember, it's going to be critical that you be able to find those vertical asymptotes. These graphs have these dotted vertical lines that the graph doesn't cross. So the graph of y equals a tangent x. Tangents asymptotes are at negative pi over 2 and positive pi over 2. That's where tangent is undefined. The tangent of 90 degrees, if you think of the unit circle, sine over cosine, it would be 1 over 0. The vertical asymptotes occur where you get 1 over 0, where these things are undefined. And then, if we think of, okay, the midpoint between 0 and this vertical asymptote, if we think of that, at that point, whatever number a is, that's where it'll be at that point. Okay, so midway between, it's up at A, and over here, it is down at negative A. Tangent goes up when you look from left to right. It does something like, oh wow, that's a bad graph. Thing you're going to have to remember. Tangent has asymptotes negative pi over 2 and pi over 2. It's going to be critical that you remember that. Cotangent's going to have asymptotes at 0 and pi. Tangent's going to be the one going up when you look from left to right. Cotangent's going to be going down when you look from left to right. So, tangent, it's T, the very next letter is U. It's going up when you look from left to right. Okay? For cotangent, a cotangent x, and again, this is where a is some positive number. Asymptotes for this, 0 and pi. Why? Well, the cotangent of pi, let's say, is undefined. If you look at the unit circle at pi, or 180 degrees, cotangent 180 degrees would be negative 1 over 0, which is undefined. So we have vertical asymptotes here, and it's going to be crossing right in the middle here. And I think to myself, okay, now does it go up or down? It's going down. Okay, so right here, midway through, it's going to be up at A, then here down at A. Now I'm mentioning these A's like that, but I think for a lot of your graph, it doesn't really matter. You can choose the answer choices without being that precise. But if this number A were a 7, then it'd be up at 7 right here. If you think of 1/4, 2/4, 3/4, 4/4. If you break this interval into fourths, you have the two asymptotes. 1/4 of the way over, it's up at A. Then it's at 0. Then it's down at negative A, whatever number A is. Asymptotes here are at 0 and pi. The asymptotes at tangent are negative pi over 2 and pi over 2. Those numbers are going to sort of follow us, especially when we get and finally define inverse trig functions, which is going to be once we're through with all this graphing. So can y'all think of a way? How can y'all remember that cotangent is the one that's got the 0 to pi, and tangent is the negative pi over 2 to pi over 2? Remember one semester telling students, I want y'all to figure out a way to remember it. And a good student, last I heard he was at Rice, said, he came up with a little rule. He said, okay, you've got to remember negative pi over 2, 0, and 0 to pi. You've got to remember these, but the way you remember that this is the one that goes with cotangent is the fact that the 0 and the O, over here there's no 0 in the tangent. So somehow or another, or if you just, the way I always thought of it was, okay, which one's undefined? Tangent's undefined where? Well, at 90 degrees. Cotangent's undefined at 180 degrees. But it's however you want to think about it. But somehow you need to remember that. Now, just like the graphs for sine and cosine don't always start on the y-axis, here we're going to be able to be moving around these. Let me just show you. We're going to go all the way through and graph. Let's say y equals 3 cotangent x, how about 2x plus pi. Y equals 3 cotangent 2x plus pi. That looks sort of nice. Well, just like sine and cosine, we can talk about finding the period of tangent and cotangent. But the period for tangent and cotangent is slightly different from the period of sine and cosine. With sine and cosine, we'd say 2 pi over the coefficient of x, because it took one complete cycle for it to make a complete. It took one loop around the unit circle to make one cycle. Well, with tangent and cotangent, as soon as you get down to the third quadrant, then the values start repeating, because in the third quadrant on the unit circle, we have negative and negative. Those are going to give all the same values as up here in the first quadrant, where you have positive and positive. If you look at your unit circle, all of these tangent values here are the same as the ones in the first quadrant. Similarly, when you go sine over cosine in the fourth quadrant, it's the same you get here. So instead of saying 2 pi over the coefficient of x, it's just going to be pi over the coefficient of x. Okay. So in this particular problem, the period would be pi over what? 2. And there'll be some homework problems probably that ask, okay, what's the period? I wonder how tricky they're going to get. If it asked what's the amplitude, don't say 3, what would you say? Not defined. Amplitude for for tangent and cotangent isn't defined. Why? Because the way the graphs just keep going and going up and down. There is no furthest distance it gets from the x-axis. The key is going to be finding these asymptotes. And we're going to find the asymptotes the same way that we found the starting and stopping point on sine and cosine. With sine and cosine, you took the angle and set it between what two numbers? 0 and 2 pi for sine and cosine. Here, the numbers you set it between is going to depend on whether it's tangent or cotangent. We're graphing cotangent. You're going to set it between 0 and pi. you're going to figure out which x value would give us an angle of 0 where there's a vertical asymptote, what x value would give us an angle of pi where there's a vertical asymptote. So this is the big difference. If it's tangent, you set it between negative pi over 2 and pi over 2. If it's cotangent, you set it between 0 and pi. So let's see, how would I solve this for x? I would, I'm going to subtract pi. So we have negative pi less than 2x less than, oh, is that 0? And then what would I do? Divide by 2, So that primary period, the one that turns the angle from 0 to pi, is going to be negative pi over 2 to 0. So there's going to be an asymptote at negative pi over 2 and at 0, which is the y-axis. It's going to be sort of hard for me to show the dotted here on the y-axis. Let me bring this up. And then here I can show it. So this is the y-axis, and here's negative pi over 2. We're going to have an asymptote there. This graph will cross the x-axis right in the middle. Now watch my pen movement. The graph either does this, going down, or it does this, going up. It's either going down or it's going up. Which one is it? You've got to remember, that's the purpose of my little TU up, cotangent, the letter after C is D, down. Cotangent goes down when you look from left to right. Tangent goes up when you look from left to right. So this is going to be going down. And if I want to be real precise about it, and I may as well, right here between this point, the intercept, and negative pi over 2, it's going to be at what y value? 3. That's what I was trying to show here. Okay? Right here, it's going to be at 3. Whatever number A is. And again, A isn't standing for amplitude, it's just a number. And like right here, it would be down at negative 3. So try to connect the dots. But generally, you can usually choose the graph just by, as soon as you know the asymptotes, and okay, draw a little curve going downward from left to right. You don't have to be so precise with the 3 the way I'm doing it right here. Okay? Y'all sort of follow what I did there? The key is going to be finding those asymptotes. I did tangent first because that's a little bit easier because you're using 0 and pi here. Maybe we should graph, I graph cotangent first because it's the easier one. Maybe we better graph a tangent one now, okay? So we will graph y equals, let's say, should we make it really messy? 2 tangent 3x minus pi over 2. I mean, we may as well go for it. Let's go ahead and state the period because there are probably some homework problems where it's going to ask, what's the period? Yeah, problems 4, 5, 6, that's all it does is this. What's the period? Okay. So, what's the period? Okay, it's pi over the coefficient of x. Am I using my invisible blue ink, or can y'all see it? Oh, it shows better up there than it does on the paper. Okay. Well, the period is pi over 3. It's pi over the coefficient of x. Now, the amplitude isn't defined. I'm going to go ahead and write that. Amplitude is only defined for sine and cosine. So, key's going to be finding those asymptotes. So you take 3x minus pi over 2, and what am I going to set it between? Negative pi over 2 and pi over 2. You've got to know that. Okay? And let's see. How do I solve this for x? I think the first thing I'll do is just go through and add pi over 2 all the way through. Negative pi over 2 plus pi over 2, that's going to be 0. Right? 0? Oh, this isn't going to be that bad, is it? And then 3x. And pi over 2 plus pi over 2, is that just a pi? Divide by 3. So if we talk about that primary interval, the one that coincides to 0, negative pi over 2 to pi over 2. If x is any number between 0 and pi over 3, then that angle is going to be between negative pi over 2 and pi over 2. So to draw it, let me see. I think I have room to do it right here. 0 to pi over 3. And let me see. I'll use black to draw the little vertical asymptotes. Like that. And midway between the interval, between those asymptotes, it's going to be crossing the x-axis. So I'm thinking, okay, is it going, watch my pen, it's going to do one of these. It either goes down when you look from left to right, or up. Which one? Up. So I'm going to draw it, not really worrying about that 2 yet. Something like that. There's just a rough sketch. In reality, I might be a little off in the sense that right here, where should it be there on the, what y value should it have here? A negative 2. And right here, it should be at positive 2. It's a really good graph there. It's a nice graph theory. Let's look at some of these problems you'll encounter in your homework. Problem number, let's see, number 1. Let me see. Should I do a blow up on this? Maybe should I magnify it more? Number 1. I'm doing a physical magnify. Just by moving it in closer. Okay, choose the correct graph. Well, we can sort of knock out C and D, right? And I coerce y'all into agreeing it's not C and it's not D. Now, when you're actually doing these in your homework, if you click the little magnifying glass, the graphs look so much better. Now, just based on tangent goes, let me see. See if I can focus this any better. Okay, I guess it's the same. Which one would y'all think it looks like? Tangent should be going up when you look from left to right, or down? Up. With that in mind, A or B? A, okay. now let's go to this next one. Tangent x minus pi over 2. Wait. Hey, we have a little, well, I better not say it. I want to say we have a lazy programmer here. Did they just do 3 choices? Let's see. So I'm hearing C. Tangent goes up when you look from left to right. And you might be thinking, well, wait a minute, the asymptotes are wrong. No, they're not. Have you set x minus pi over 2 between negative pi over 2 and pi over 2? Aren't the asymptotes going to turn out to be 0 to pi if you added pi over 2 all the way through? So it is C here. Okay. C. Oh, what about number 3? Now you should be able to do these without just punching it into a graphing calculator. If that was the intention, be just to punch it into a graphing calculator, there's a lot harder problems to assign. My math lab is filled with these problems where it gives you the graph and says, write the equation. And if all you were supposed to do was punch into a graphing calculator, those are the things we'd have to be assigning. Okay, so my math lab is full of all these problems to get around you being able to just punch it into a graphing calculator. But you'll notice I was very nice. I didn't assign any of those. I'm just saying, don't just punch it into a graphing calculator. Okay, like this one. X, cotangent x plus pi over 11. Well, like B, it looks like it's been shifted